Here's another sample problem where we are comparing two things and don't have all of the information for both of those things. I'm going to give you an opportunity to solve this problem on your own piece of paper, and then we'll walk through it together. So it will pause and allow you to get some work down on your paper, answer some questions before we move on. Your problem is the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? So again, we are starting with the most important information first, and we do that by answering two key questions. Your first question is, what are we comparing? Take the time now to write down on your paper what two things we are comparing. Your second question is, what are the totals in this problem? See if you can go through and find both of the totals for this problem. So as I read through again, I'm going to go find that information. And the first question I am asking myself is, what two items are we comparing? I'm going to use my highlighter tool to find those. So it says the admission fee at a small fair is $1.50 for children, $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children? So here's your question. So we are comparing children with adults. So how many children attended and how many adults attended? So we can set those up as our variables, as those are the two things we're comparing. So for the sake of this problem, we're going to call children X and adults are going to be represented by Y. You can choose any variables you like. We don't know how many children and how many adults attended, which is why we're using variables for those. Our second question that I often tell kids to help them walk through these problems is, what are the totals in this problem? So now we're going back and looking for more information on what we want our answers to be. So again, I'm going to choose my tool. And I can see here that I know on a certain day a total of 2,200 people attended and spent or entered to pay the fare $5,050. So those are my two totals. So as I'm setting up my equations, I'm going to use those. So I'm going to have an equation. One of them is going to equal my total number of people, which is 2,200. And my other equation is going to equal how much those people spent to get into the fair, which is $5,050. So now I have my totals, I know my two variables, and I have to go in and fill in my equations for these in order to solve. And I can do that just by reading back through the problem. So you can see the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter. So I know there are a total of 2,200 people who enter, and I also know all of those people are either paying a children's ticket or for an adult's ticket. So I can say that I know the number of children that came into the fair, which is X, plus the number of adults that came into the fair, which is Y, equals my total number of people that entered the fair that day, 2,200. That's one full equation that's representing the total number of people coming into the fair, both X and Y, which are my children and my adults. For the second equation, I have an added element of cost. So not only do I know that I have children and adults entering the fair, but I also need to know how much everybody paid. So looking at the problem again, you can see that we know that $1.50 is a children's ticket, and we know that $4 is an adult's ticket. So I have to add that into my equation in order to get my total cost. So I'm going to tie those numbers directly to what they represent. So I know that $1.50 is a child's ticket, so we'll start there. $1.50, and the number of children I don't know yet, so we have called that X. That's what we found in number 1. Added to the number or the cost of adult tickets, which is $4, for the number of adults, which is Y. So here's the start of my equation, and I'm going to total that to my cost, which the problem has told me is $5,050. So here I have two equations set up that's going to compare the cost of children tickets to the number of adult tickets. Make it fit on my page. So to summarize, I know that I've got two types of tickets being sold in order to come into the fair. Those tickets are children's tickets and adults tickets, and I know I have a total of 2,200 tickets. I still don't know how many of each of those I have, but I do know the cost of $1.50 is for the children and $4 is for the adults, equaling my total cost. So this is how you set up your problem for systems of equations. Now I have two equations. I know they're a system because their variables are representing the same thing in both equations. Both of my x's are representing children. Both of my y's are representing adults. So as you go on, we're going to show you 3 different methods of solving these types of equations. But it's good to just practice pulling out the information and making the equations from these word problems to get started.